Welcome back to the lab. If you're anything like me, you might have a 3D printer at home, and if you're using a 3D printer at home, you might have some of the same worries that I do. Have you ever been worried that your printer might just spontaneously burst into flames? I know I have. In fact, because of those concerns, before we even started this project, I had a webcam stream going. I've updated my 3D printer firmware to include Runaway protection. I regularly inspected the cabling, but it still just wasn't enough for me. You know, I've got a lot of stuff that I'd really prefer to keep. Some of these things are truly unique, one-of-a-kind outputs from our previous projects. That kind of thing, that kind of stuff would take weeks or months to recreate. Sure, maybe they don't have a large monetary value, but it means a lot to me. So let's say you've got some stuff like that. How can we protect ourselves from a 3D printer? Like we mentioned, our concern is, I don't know, maybe even a little irrational, but it's like these pieces of equipment, they aren't really built to be safe. They aren't really built to be fault tolerant and resistant to setting themselves on fire. In fact, they've been proven to catch fire sometimes. So I feel like we need some kind of external device that's constantly observing our 3D printer, just constantly watching the temperature, and if the heated bed or the hot end get too hot, it'll cut power to the printers right at the mains core, just rip it out of the wall. That sounds like that could work. Basically, I think we need a temperature monitor. Funny enough, we've been building a temperature monitor project over the last few weeks. We've been designing, testing, and sharing our work. As a part of this project, we just made a little circuit board. This circuit board, in fact. And this little board has 2 thermocouple inputs, a power supply on board, some analog stuff in the middle, and 2 relay outputs. We built this PCB because of a problem that we just described. We built this circuit board because currently existing thermal runaway watchdogs, both built into 3D printers and external, do not sufficiently reduce the risk of fire while printing unattended. That problem bothered me to my core, so I decided to do something about it. And here's what I did. I created a device which uses this circuit board, and this device monitors the hot end and heated bed temperatures. And then it gives us an adjustable threshold so we can decide how hot our printer can get before it'll cut power. And of course it does that with the relays. I wired mine up to a couple power entry modules, and that allows it to switch mains, but switching mains can be a little dangerous. So only connect electronics to the grid if it has been rated by an appropriate safety agency. This design, the design that I'm sharing with you, it's for educational purposes only. There are relays capable of switching DC power, just like these are rated to switch AC, so if you decide that you like our design, you want to build something like it, you can use this design, to teach yourself about how relays work and how comparators work, but ultimately, your design is your own, so do what feels best to you. Before I get too far into this video, telling you about how I can finally sleep at night, all my problems got fixed, my dog came back to life, and I won the lottery, I need to share something very important. This device does not address every hazard of 3D printers. For example, some 3D printers don't catch fire due to thermal runaway, where heat is added to the hot end or the heated bed excessively. Sometimes fires start because of arcing and loose connectors, a wire coming loose within the printer itself, and I'm sure there are many, 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 many more ways that these 3D printers can fail catastrophically. Technically, I suppose we could use a bunch of these, just take one, copy it, make like 14 of them, and just put a thermocouple everywhere that there could possibly be an ignition source. I could take 15 of these boards, wire up all those thermocouples to different points in the printer. Well, but that's just not really the point. The point of this project is not to attack every single opportunity of fire, every little bit of risk, but it's meant to attack the most probable points of failure. Specifically, this temperature monitor is meant to attack the points of failure that are most likely to occur while printing. That means that double faults are pretty much irrelevant. We only need to think about one fault. While we're talking about faults, the 3D printer firmware upgrades that I've done actually do a lot of protection for the printer. And the only real problem is when there's a software glitch or a hardware failure within that printer that might cause the 3D printer to lose control of the heating elements. If the software has already tried to turn off the heating element, but it hasn't turned off, what's it going to do? Try to turn it off again? That's where this comes in. For example, If the clock generation circuitry in our microcontroller in that 3D printer were to fail, it would just stay wherever it is. It wouldn't change state ever again. And that would be kind of a problem. It's very important that our temperature monitor is reliable. So that's why we designed our circuit to be mostly single fault tolerant. For true single fault tolerance, and by the way, single fault tolerance means that there can be a failure in the system and it still operates correctly or resolves into a safe state. So 2 of these monitors would need to be used for that, to redundantly measure the temperature and redundantly make the decision. And that's because the thermocouple monitor chips haven't been duplicated in our system. So other than that, it's single fault tolerant. But that's just a long way of saying that we're not single fault tolerant, and being almost single fault tolerant is still not being single fault tolerant. Maybe that's just being negative, because with exception of the actual monitor IC and the first comparator that checks that threshold against the adjustable one, if anything else fails in the circuit, whether that be a thermocouple getting unplugged, or power failing to the monitor circuit, or a component on the circuit board failing short or open, our printer will reliably turn off in those conditions. That's pretty awesome. But I don't just want you to blindly trust this circuit. I want you to really understand how it works. That's why we've been discussing the circuit theory that makes this design work throughout our project playlist. So I won't dive too deep into that theory right now. To make a long story short, this design allows our 3D printer to operate normally until the fixed temperature threshold is reached. If that threshold is exceeded, our monitor effectively judo kicks the power switch, forcing the entire system to shut down. Or at least, that's how I like to imagine it. Maybe it's more of like a click, but you know. I modified my temperature monitor to provide 12 volts for the hot end cooling fan, and that's from the temperature monitor itself, which is pretty handy. That prevents a few clogged nozzles and ruined days. The reason why it does that is because the hot end cooling fan is kept running even after we've removed power from the 3D printer. That allows the hot end to cool down correctly, even though we're shutting down in a pretty brutal way. This all sounds great, but does it really work? Well, yeah, it does. We experimentally verified temperature accuracy, and we're currently running an extended operational lifetime test. We've observed 500 operational hours of this design with no misbehavior so far. That is a great start. Tripped temperature monitors stay tripped until power is removed and reapplied, and untripped temperature monitors allow for normal operation until the temperature threshold is exceeded. I'd love to test this design over temperature ranges over a much longer time, but that takes some serious gear. We need to get a lot of these boards operating in temperature chamber and cycling them. All this to say, I'm really excited. And we haven't fully tested this. We haven't done every possible test that we should do if we wanted to make this a product, but I think that we're only one step away from completing our objective. I think we're close to designing, building, and making publicly available a thermal runaway prevention mechanism for the hot end and heated bed of a 3D printer that is in itself single fault tolerant, such that the failure of any one component in the system either has no impact on safety or causes the system to fail into a safe state. If you've been following along from the beginning, that sentence probably sounds very familiar. There's only one problem. Selling a product requires some, well, basically, in order to sell this thing to you, we need to say this design is complete, safe, and works, but I can't say that. As I tried to explain in our video about safety standards, requirements, and isolation, saying something like that and really believing it requires a full evaluation of a design by a safety agency, and that hasn't happened, so I can't sell this as a product. I know, there are people in the world that sell stuff that's probably more dangerous than this. In fact, I've bought some stuff that is more dangerous than this. But I can't sell this to you because selling this as a product or even a kit without certification, I think would be morally wrong and against engineering ethics. I can't do it. I want to, but I won't. Getting a design certified is very expensive, and I can't really do that for this project. It's just not really worth it with the resources that I have. So where does this leave us? Well, I'm stuck in a conflict, right? The goal of this whole project is to make the design accessible to you, but directly giving you the completed design defies my understanding of engineering ethics. Well, conflicts like this happen more often than you'd think, so here's how I want to manage it. If you want to build a temperature monitor, if you like this design and you want to make it, you have two options. Option the first we've released the complete reference design to members of our Trust Me, I'm an Engineer Patreon members. Well, I think you get the joke. This includes access to our complete KiCad design files for this project, among some other ones that are coming very soon. So if you'd like to take this reference design, which is not suitable or safe for any application, and modify so that it is safe, does something, or works for your application, something like that. If you want to apply your skills and knowledge to make this not a reference design, but actually work, do that. Go ahead, join the Patreon community, download the files, and make it work. And it really breaks my heart, but I need to take a moment to tell you about the state of this design. It's going to sound a little doom and gloomy, maybe a little boilerplatey, legalese or whatever, but it's important that I take the time to explain the state of this design to you before you might be inclined to duplicate it. Just know this design isn't finished, and I can't guarantee that it works. If you decide to take our reference design, which is meant as an educational tool for educational purposes only, and you build the design in physical form and use it for anything, you'll be responsible for ensuring the design works, and you'll take on all the risks and responsibilities involved if it doesn't work as intended. I'm telling you, flat out, this design serves no purpose. It does nothing, and nobody should ever use it in physical form for anything except for learning, unless you think that it's suitable to do so. If you decide to use this temperature monitor relay output to control mains voltage, for example, because you believe that this design is suitable for that, I can't stop you. I'm just saying that I don't know if doing that is safe until the design has been properly evaluated by a safety agency, and it hasn't been, so I don't recommend that you apply this to any voltage that exceeds the self limit for your country. Don't get me wrong, our testing was promising, our analysis was relatively complete. I have no reason to believe this design doesn't work, but I don't have the official testing to prove that it does either. So until I know for sure, I just have to assume that it doesn't work and it isn't safe. That might sound a little confusing. It might sound like I just contradicted myself, but I'm encouraging you to dive in, finish the design that we started, verify that it works for your application, and send the design files off to be assembled somewhere, just like we did. I hope that you can enjoy the work that we put into this project and, kind of get some value from it. And if you're willing to shoulder the burden of certifying that the design works and accept the risks involved if it doesn't, maybe this option is for you. For people working in the electronics industry, this should be pretty easy stuff that hopefully saves you a lot of time, like just opening the design and exporting some Gerbers and sending it to the fab house. That really doesn't take too long, so hopefully you can save some time by leveraging the work we've already done. We're going to be releasing a couple more designs to our Patreon members as we go on, just as we build them, as we get them ready sort of basis. No real schedule there, but just doing a rough calculation on my own, if you value your time, I'm confident that the time you'll save through direct reuse of our design files will be worth it. Even if you have to go through the analysis, it'll save you a lot of hours. So now, if you're anything like me, you've probably got enough recurring expenses, and you might not really be into that whole Patreon thing, or maybe you don't have, money to throw at that right now. And if that's you, I totally hear you. There's no obligation. I love that you're here just watching, being a part of this community. So there's a second way that you can get your hands on a temperature monitor, and that's through our box of junk on Etsy for a limited time. The box of junk is pretty great already. It's just filled with little bits of circuit boards, failed designs, working designs, and maybe a little something special, like the temperature monitor, some random piece of EEforEveryone history. The contents of that box is not guaranteed. We're literally shipping you scrap PCBs and, whatever else we've got laying around. So you could get anything, but I'm telling you that the next 4 boxes of junk to be sold will have one of our partially assembled temperature monitors, Scout's Honor. It'll be a copy of exactly what we finished building in our live stream. That means that you'll only need to do what we did during our live stream. You need to assemble a couple SMT components, connectors, switches, and relays, but all in all, almost everything's already on there. By the way, this board's being shipped as scrap that just happens to have components on it, but I think I might just wrap this piece of scrap in some bubble wrap and an anti-static bag for the one I've still got on the bench, just in case. Just in case someone decides to unwrap this scrap PCB and maybe wants to reuse it for something. They could use it for anything. It's a general purpose board with relay outputs. So, if you'd prefer that, that's also an option. To summarize, this whole project is for educational purposes only. The complete reference design is accessible through Patreon, and the next 4 boxes of junk to sell will include one of these partially assembled PCBAs that we got from JLC PCB. No warranty or functionality is guaranteed, but I am happy with what this board does for me. Check out our live stream where we tested this design. I will drop a link somewhere. Just so you know, there are 3 known defects in this design. The hole spacing of our spade terminals is incorrect. A 0-ohm jumper needs to replace the transistor currently controlling the auxiliary 12-volt output, and I decided that a JST-XH connector would be much more suitable for the auxiliary power output than the spade terminals currently being used. I haven't had the time to make these changes yet, but it's on my list, and I promise I will update the design files on Patreon with a second revision once these corrections have been made. What I did for now is just cut off one leg of the TE spade terminals to get the thing installed, which is pretty hilarious. Basically, what I'm trying to say is that even though it's difficult to talk about a design like this without taking on risk, I'm really excited about this project. I'm really excited about this temperature monitor. We set out to solve a problem, and I feel like we've done exactly that. If you like this video and you can't wait for more, let me know by getting subscribed, hitting that like button, and leaving a comment down below. Coming up soon, we'll be diving back into the UPS project, and we are going to be doing more little projects like this. I had a lot of fun, and I hope that you learned something along with us. You know, I bet we're going to be doing our next project before I can even blink. All right, maybe a little longer than that, but I'm really excited about it. All right, we've got some cool stuff. We've been talking about making an electronic load that's programmable for a long time. I want to do that. I want to test the UPS. We're going to have some wicked fun in the shop. But most of all, I hope that you learned something great today. I hope to see you again soon. So thanks for watching EE for Everyone, and thank you for staying till the end. Bye.